This is the video for routine 100 of the perspective game. It sets the animal index to 0, and it fills the 100 values that animal get with 0. This indicates that no pictures have been taken by the camera. Then it fills 3,000 values at tree number with value 416. That's the picture number for a particular tree, and this is to make sure that there is a tree number at every position. Then it sets up information it uses to move the ground with the trees. However, it only has two movements of the ground, x1 and x2, and then it adds to it a +1 and 2. That means there's really only two movements of the ground with the trees, but you cannot detect that that's true. It looks to you like the ground is moving with the trees. Next, it resets all the probability distributions. That's because later on it's going to randomly pick the trees that are going to be in each position. Then it sets the next tree number to 0, the next animal number to 0. Then it's going to create a factor here to change the number of trees in each row in the forest. When you start at the back of the forest, there are many trees. As you come closer to the camera's position, there are fewer trees. This is the factor it's going to use, 10,000 divided by 8,910. Then it sets T to 100, sets L to 0, and then it's going to go around a loop here for I0 down to 20. That's going to go around 21 times because there's 21 rows of trees. And it's going to start out in the loop by rounding T and then setting the row factor sub I to T, dividing that by 10,000, setting L to T, and then here it's going to put the cumulative value. It's going to set a cumulative value to L, and then it's going to divide it by 1,000. Then it's going to multiply it by this factor that we created up here, H times T, and then, as I say, it's going to go around for each one of the rows. Now we'll take a look at the picture, and we'll see here in the front there's only 4 trees going across, but in the back here there are 40 trees in a row. Now I've highlighted the next section of this routine. It sums the 21 row factors and puts it in S, sets A to 170. That's the change in Y from the first row of trees to the last row of trees. Then it divides S into A to get an individual amount. Then for I of 0, and down here we have next I 20, so it's going to go around for each row. It's going to set the Y value of the ith one to the cumulative factor, but then multiply it by A. That's the change in Y for each factor. Then it sets the tree center to 30. The trees in their pictures are 60 high, so 30 is half of that distance. Must remember that the pictures of a tree are not going to be placed starting with the base of the tree, but at the center of the tree. So then it multiplies that by the row factor to say for that row of trees, what's the distance to the center of the tree? Then it subtracts the tree center from the Y value that it calculated. So it's adjusting it for the center of the tree. Then it rounds that, and then it adds 150 to it because the sky starts first before it even gets to the trees. So it has to drop down 150 values of Y. Then it sets J to 0, and then for I of 0, and down here to 20. So again, for every one of the rows of trees, it's going to go around here. it's going to set the row count to 3, but then it's going to divide it by the row factor, and then add an additional 1 to the row. That's because it needs another tree, because they're going to move from the right, well, from the left side towards the right, and you need a tree in every position. Then it sets the jump it needs to have, because it's going to move 400 values of x, and then it divides that by the row count for each one of the trees to see how much space is between each tree. Then it sets the row half to that same value and divides it by 2. Then it says the row advance of I is set to that value also, and divides it by 50. Then it sets the start of each row at 600. 600 is the beginning x value for the trees. Then it says subtract the row jump x of I from that value, and then set the row base value to the start value, and then set row t index to j, and then add 100 to j. Each one of the rows is going to be separated by 100. Now I've highlighted the last section of this routine. Starts out, it says for RG 0, and down here to 20. So it's going to go around here 21 times, once for each row. Then it sets TG, the row T index of RG. That's what it calculated up here. They're 100 apart. Each one of the rows of trees are indexed 100 apart. Then it says for P of 0, the P is the row count. That's how many trees are in that particular row. One at a time is to go around this loop. And here's where it places each tree into the list. This is a routine which we'll go over later. It's at LA. And each time it goes around here, it adds TG to this index. And then it says for the next P, for the row count. That's how many trees there are in the particular row. And then it says for the next RG for each row. So for each tree and each row. After that's done, it sets the ground picture number to 572 and sets PS to that ground picture number, and then here picture goes and gets that picture. The reason this is being done is because you should get the pictures before you display them, because when you're trying to display it, it may not have read it in yet from the server. Same for the sky. It sets the sky picture number to 379, then sets the picture's control register, PS, to that number, and then goes and gets that picture. Next, it's going to go around to get the trees. It says for I of 0, down here to 57, means it's going to go around 58 times. Each time it's going to tell it to go get another picture. Again, it's so that the pictures are ready when the forest is going to be shown. Then for I of 0, down here to 21, this is for the 22 animals. It's going to set, again, the control register PS for pictures to 549 plus I, and go get that picture. Alright, this is the end of routine 100 for the perspective game.